Hello guys, welcome to my YouTube channel. In this video, we will talk how we can apply gradient descent to our logistic regression algorithm. Okay, so as you already know how gradient descent works, I have already explained it in my earlier videos. So it tries to update the parameter values so that we can arrive at the global minimum. Okay, on the curve of the cost function. So here I have written down the hypothesis for logistic regression, right? So this is also called as sigmoid function, okay? So sigmoid. So it is given by 1 by 1 plus e to the power minus theta transpose x, okay? Now the cost function for logistic regression is minus 1 over m summation from I equal to 1 to m yi into log of h theta of xi plus 1 minus yi into log of 1 minus h theta of xi. So this is the cost function for logistic regression and this is derived from a principle of maximum likelihood. So this part also I have explained it in a separate video where I have talked about log of odds and likelihood and maximum likelihood. Okay, so please go and check that video as well. So this is the cost function we have, and this particular cost function will give us the convex shape so that we can apply gradient descent to this and then update our thetas in such a way that we arrive at the global minimum point somewhere here. Okay, so that the cost will be minimum, right? So this is our main aim. The algorithm for gradient descent is given as, first we will initialize the thetas at random. You can start by initializing them to 0. These are also called as learnable parameters or the coefficients, right? Then we will compute the hypothesis. Then we will calculate the cost function, right, based on the hypothesis. And then for the parameters that we have to learn, that is number of parameters is equal to n, that is the number of features, we will apply this rule to update the parameters, that is theta j is equal to theta j minus alpha into d by d theta j of j theta, right? We are applying derivatives, calculating the first order derivatives, partial derivatives on our cost function to move the theta values right or left so that we arrive at the global minimum in the cost function. And we repeat this step until convergence. So when I say convergence, we have to arrive at this particular point where the cost is minimum. Okay, that's the point of our convergence. And we have to update these thetas simultaneously. Okay, so this things remains same. This how gradient descent algorithm works in a general way, I have made a separate video and uploaded earlier. Please go and check that out. So now coming to this partial derivative, this d by, so let me just scroll it here, d by d theta j of j theta, right? So how we can compute this for our logistic regression cost function, right? So our logistic regression cost function somewhat looks like this, so which is derived from maximum likelihood principle. So if you guys can derive the partial derivatives for individual features with respect to these training examples, you guys will arrive at the equation something like this. So the partial derivative for the cost function is given by 1 by m summation I is equal to 1 to m, right, h theta of xi minus yi, okay, sorry, now let me just correct the brackets, h theta of xi minus yi, okay, into xi of jth feature. Okay, so this is how the partial derivative with respect to the cost function is derived. So I am not going into detail on the derivation part. So if you guys know a bit of calculus, you can easily arrive at this particular formula. So this is how we update the parameters. So if I just substitute this particular equation in this part, it will look like theta j equal to theta j minus alpha into d by d theta j, right? We have to substitute this here. So alpha into 1 by m into summation of I is equal to 1 to m h theta of xi minus yi into xi of j. Okay, so we will repeat these steps multiple times until we arrive at the minimum point where we will have the minimum cost function. So we have to repeat this step, repeat this. Okay, now if you guys can relate it to the linear regression derivatives, partial derivatives, you will see there is a strong resemblance, right? So even the linear regression gradient descent algorithm, if you substitute the partial derivative, will look similar to what we have here, correct? But the difference is with respect to the cost function that we have here, x of I, right? So this is 1 by 1 plus e to the power minus theta transpose x of I, correct? With respect to logistic regression. But in linear regression, this changes to h theta of xi is equal to theta transpose xi, correct? So this is the main difference where logistic regression gradient descent differs from linear regression gradient descent. Okay, so in the same way that we apply gradient descent to move the parameters either left or right based on the slope of the line that we get at particular point of the initialization of the theta, we do the same things with respect to logistic regression as well until we converge at this particular point. Okay, so that's it about this video. So if you guys have any questions, please reach out to me via comment sections. I will try to answer it. So till we see in the next video, happy learning. Bye bye.